Let's look at this problem. You are supposed to travel from this starting point of a pond to the opposite side of the pond, and then your plan is to swim from the starting point. How about we just call the starting point as A and the ending point as B? So the plan is to travel from A, you swim across from A to P, and then you walk from P to B. Of course, when you swim, you swim at 2 miles per hour, and when you walk at 3 miles per hour. So we need to find, the problem is to find a P, choose a point P, so that the total travel time is the smallest. So we want to minimize the total time for the trip. Now, to find the total time, we certainly need the time for this particular segment from A to P, the straight line, and then the time from P to B, this arc. So it's the time for this segment AP plus the time for the arc PB. In order for us to find each time, we do need the distance from A to P and from P to B. So to find the time for this segment AP, we need the distance of this segment divided by the speed, which is 2 miles per hour. So now it all comes down to how do we find this AP, right? And similarly, the time for arc PB is equal to the arc PB divided by the speed, which is 3 miles per hour. Again, we need to figure out this PB. Now, let's introduce a variable. The variable in this case actually will be, let's define this P when this is P. Let's define this angle as theta. So I'm going to zoom in here. Let's define this angle as theta. And then if this is theta, how do we find the length of this segment AP? This is what we are going to do. There are a couple different methods. The first one is you can draw the altitude from this center O to this segment AP. When this is altitude, these two segments should be equal. This one should be equal to this one. In other words, the foot of the altitude should be the midpoint of the AP. With a little geometry here, we assume that we are going to skip that geometry, the proof of the geometry. And then because we do know that the radius is 1, right? So I'm going to label that. Radius is 1 mile. And this angle is, if you call the whole angle as theta, this angle should be theta over 2. Now, and then using the trigonometric function sine of the sine function, this little segment, which is half of this segment, which is half of AP, right? So I'm going to write this down. So half of AP, this segment over the hypotenuse, which is this particular one, which is 1, equals the sine of the angle. So this is the angle, which is half of theta. So half of theta. In other words, if you simplify, in other words, what is not AB, but AP. So this is supposed to be AP. So in this case, AP should be equal to 2 times sine theta over 2. So this is the first way that you can find this AP. So I'm going to write this down to my problem here. So we just discussed, this is going to be 2 times sine of theta over 2 divided by 2, which means it is equal to sine theta over 2. This is the time for traveling from point A, starting point, to a point P on shore. Now let's look at the other one. To find PB, which is the arc length. So this is the arc length for this angle. And if we define this as theta, then this obviously is pi minus theta. The arc length formula, so the arc length formula is equal to the radius times the corresponding angle, the radius times angle. So in this particular case, the radius is 1, and the angle here, because we define this as theta, therefore this is pi minus theta, the angle will be pi minus theta. So with that, we do know that the time traveling from P to B along the circle should be equal to, so pi minus theta divided by 3. So therefore, the total time that we need to travel from the point A to point B will be equal to, according to what we had previously right here, it should be equal to sine theta over 2. This is the time traveling from A to P directly, swim across, plus pi minus theta over 3. Now, what is theta equal to? Theta. So the domain of theta is, when theta is 0, that means this P overlaps with A when theta is 0. That means you walk all the way from A to B. When this theta is pi, which means the whole straight line, that means you're going to swim across from A to B. So these are two extreme cases. Now, so with that, we do know that theta is going to be from 0 to pi. And then we want to minimize the time. In order for us to minimize the time, we need to find a critical point. And this is a nice problem because the domain of the variable is in a closed interval from 0 to pi. So we are going to find the first step now is to find the critical points. I'm not going to call it this as first step, of course, because we already discussed a lot, right? So I mean, once we get the function and the domain here, the next step is to find the derivative with respect to t in this case. Chain rule is applied. Derivative of sine is cosine u times the derivative of u, which is 1/2, plus, now when you look at this guy, you can think of this as, if you think of this as pi over 3 minus theta over 3, so you can think of this as plus pi over 3 minus theta over 3, right? And the derivative of pi over 3 is just 0 because it's constant. And derivative of negative 3 theta over 3 is actually minus 1/3. Minus 1/3, right? Okay, that's the explanation. And then you want to set this to 0 to find the critical points. So let's do this, solve this equation. So 1/2 of cosine theta over 2 equals 1/3. Cosine theta over 2 equals 2/3. And now you need to find the theta over 2 using the inverse of cosine function, right? Cosine inverse of 2/3. And this, actually, if you use your calculator, it is about 0.841. Make sure that your calculator is in radian mode. this is equivalent to theta equals 2 times approximately equal to 2 times 0.841, which is 1.682. This is radian measure. It is about 96 degree, about 96 degree. Now let's figure out the because we are not yet done. We just found the critical points. Secondly, the last step, we want to minimize the time, which means we need to find a minimum in time, right? Minimum time. So we need to check the time at point 0. Why 0? Because this is a closed interval and 0 is the endpoint and pi is the endpoint as well. So t of 0 is equal to, and where's our function t? T is right here. This is the t, so plug in 0 into t. So we'll be sine 0 over 2 plus pi minus 0 over 3. The answer is pi over 3. Pi is about 3.14. If you do this algebra, it's going to be close to 1.0, close to 1.05 hour. And then you want to check t of 1.682. This is the critical point. This is actually the critical point. So this will be sine of 1.682 divided by 2. By the way, this is supposed to be approximately equal to, plus pi minus 1.682 divided by 3. And then after the algebra, this is about approximately equal to 1.23 hours. And lastly, t of pi, which is sine pi over 2 plus pi minus pi over 3. This is sine of pi over 2, which is actually 1 hour, right? So by comparing these three, you do see that this is actually the smallest number. Therefore, you can make a conclusion. So when this is pi, what does that really mean? When this is pi, that means if you look at the graph again, that means this angle theta is equal to pi. That means it's 180 degree angle. That means you're swimming across directly. So with that, you can make a conclusion. Therefore, swimming across directly, right? Across takes the shortest minimum time, which is 1 hour. So this is it for this particular problem.